Okay, class. So, we have to solve the problems ng ating conversion of energy para mas maintindihan natin siya. So, I have prepared here 4 problems. 4 problems na galing sa ating board exam. So, we will solve this live. Okay? So, here is problem number 1. Problem number 1, sabi siya, during a non-flow, bigyan natin ng highlight. During a non-flow process, the internal energy, or the U, of a fluid changes from an initial value of 500 BTU per pound. So that is specific internal energy. That is specific internal energy to a final value of 440 BTU per pound. If 30,000 feet-pound per pound of work is performed by the fluid. Performed by the fluid. So ano yan? Yung work mo ba is positive or negative? Kapag to the system, that is added. So pag performed by the system, so that is negative. Okay. Compute the quantity of heat in BTU per pound needed to. Needed to or remove. Hindi natin alam kung positive eh. Added to or remove the negative from the fluid during the process. So, closed system yan. Wala kang flow. Ibig sabihin, kapag non-flow, wala kang P1 and V1. May given ba dyan P1 and V1? Yung mga P1. Wala. 0. V1. 0. P2. 0. B2. 0. Ay, wala kang mga given na ganito. Non-flow, wala ka namang velocity dyan. V1. Wala. Okay, 0 pa rin. Wala ka rin V2. 0 pa rin. Meron ka bang height na binigay? Day 1? Wala. 0. Day 2? 0. Ano lang ang binigay sa'yo dyan? Yung U. That is initial value na U. Ito, 500. And then final value na 450. 440. Okay, lista natin. U1 is 500 BTU per pound. U2. The U2 is 440 BTU per pound. Ano pa binigay niya? Nagbigay siya ng amount of work that is performed by the fluid. So that is work performed by the system. So that is performed by the fluid. I think this is positive. Performed by the fluid. Ayun. Performed by the fluid, hindi pala no system. So that is positive. Yan. Okay? So the work is positive. So 30,000, 33,000 ba? 30,000 lang pala. 30,000 and 30,000 feet pound. 30,000 feet pound per pound of work. Now, ilista muna natin yung energy in, energy out. So, kapag meron tayong heat, ay equal yung heat na yan sa total ng KE, yung change in KE plus the change in potential energy. Potential energy plus yung change in flow work, that is the change in P and B, plus the change in U, plus the work. Ngayon, wala tayong KE, 0. Wala tayong PE, 0. Wala tayong flow work, PV, yan. Meron tayong delta U and W. Now, for delta U, hinahanap natin heat ha. Meron tayong delta U. So, U2 minus U1 plus the work that is performed by the system. What will be the answer here? Okay, so 440 minus 500 BTU per pound. Ngayon, ito naka-feet pound per pound. Di ba ang conversion unit ng feet pound per pound? Recall. 778 feet pound per BTU. Okay, yan ang conversion natin. Plus, the work is 30,000 feet pound. Okay, divide mo ng 778 feet pound per BTU. Anong kulang? Yung pound. Ayan o, yung pound sa ilalim. Now, this is cancelled. Okay, so this will be, excuse me, 440 minus 500 plus 30,000. Lagyan natin parenthesis para may PEMDAS tayo. Plus 30,000 divided by 770. So the answer is negative. Negative 21.44 BTU per pound. So is this heat added or rejected? Since negative, this is rejected. Yan. So kapag negative, rejected. Siyempre, kapag positive, tinanggap ka. Pag ni-reject ka, negative. Okay? Ganun yung malalaman nyo. And for number 2, problem number 2, when steam expands through a nozzle from a pressure of 300 psi. Ano ba yung nozzle? Okay, sir, ano yung nozzle? A nozzle is a parang passageway na kung saan pwede siyang mag-contract or mag-expand at dulo. Ang tawag dito, pag ang nozzle mo ganito ang flow, from a bigger area to a smaller area, ang tawag dito is the converging nozzle. Ba't ba ginagawa yung converging nozzle, sir? Para magkaroon ka ng mas mabilis na velocity ng iyong fluid. Faster velocity pagdating din sa dulo. And then, mag-create ka na mas mataas na kinetic energy. You will add kinetic energy to your system. Kaya ka nag-iimbudo or nagno-nozzle. Sir, paano pagbaliktad ang nozzle mo? Papalaki. Yan. Base sa fluid flow mo, ang tawag dito is a converging. Diverging nozzle. Yan. Ibig sabihin, kapag gusto mong yung fluid mo is pabagalin. From mabilis dito, pababagalin mo ngayon yung fluid mo. Okay? Yung V2 mo is going down. Pababa, ito pataas. Tapos yung area mo, pababa. Dito yung area mo, pataas. Yan. Yun na yun. Kaya ka nagno-nozzles. Okay? Para para maapektuhan mo yung kinetic energy of the fluid. Sir, ano ba yung throttling process? Kapag nozzle, meron kang throttling process. Ibig sabihin, yung process na yun is at constant enthalpy. Yan. Okay? Yun lang yung mga common ideas na dapat yung tandaan kasi tinatanong din yan pagdating ng inyong board exam. Ngayon, going back, meron ka daw dito from a pressure of 300 psia. So, initial pressure, 300 psi. To a final pressure of 5 psia. Bumaba yung pressure. Okay, and an initial and final enthalpy values. Okay, initial. And then final enthalpy. Respectively, calculate the final velocity in feet per second. Neglect yung inlet velocity as gravitational effect and heat loss through the casing. So, paano yun, sir? Ilista mo muna. Energy in equal to energy out. Ayan. So, PE 1 plus AE1 plus U1 plus workflow 1 plus Q equal to yung PE2 plus KE2 plus U2 plus workflow 2 plus the work. Okay. Sabi dito, tandaan nyo, di ba? Note. Note. Enthalpy is equal to, ano? U plus workflow or PV. Yan yung enthalpy mo. So, pwede nating palitan ito. Ayan. Pwede natin palitan to ng enthalpy 1 at ito, palitan natin ng enthalpy 2. Yan. So, we can cancel out yung sinabi niya dyan. Wala tayong heat effects. Yan. Yung initial, wala tayo nito. Wala rin tayo nito. Wala tayong heat losses or heat gain. Wala rin tayong KE2. So, meron tayong KE2. Meron tayong H2 tsaka H1. And then, work. Ang tinatanong dyan is, ano? Okay, may binigay bang work? So, walang binigay na work. Ay, wala ka ring work dyan. Okay, so ang natira is enthalpy tsaka KE2. So, pwede natin gawin to, H1 equal to KE2. KE2 plus H2. Ngayon, equate natin. Ano ba yung KE? Okay? KE is equal to B squared over 2G. Yan. That is KE. Now, wala siyang mass ha. Wala pang mass yan. No mass effects. So, kunin natin yung sa KE. That is B2 squared over 2G. Yan. B squared over 2G equal to, lipat natin dito, H1 minus H2. Ang kinukuha natin is velocity lang naman. May meron na tayo. Pwede natin to i-simplify. Okay? So, i-multiply ko na lang itong 2G dito. Yan. So, equal to 2G tapos yung enthalpy H1 minus H2. Tapos B2 squared. Ngayon, kunin ko yung square root of both sides. Algebra lang to ha. So, dapat kapag kailangan na i-simplify muna. Akong ginagawa ko, algebraically, isinisimplify ko muna equation. Para mamaya, pag pinasok mo yung value, kasyang-kasya na lang siya pagdating ng iyong calculator. May balik tayo dito. In order to solve for V2, V2 is equal to square root ng 2G tapos yung change in enthalpy. Hindi yan height ha. So, square root. Ano ba yung G dyan? That is 32.174 feet per second squared. Ngayon, meron ka ditong H, which is 1187 minus 1041. Kaya lang, anong unit nila? Ang unit is BTU per pound. So, you have to, mali pala, you have to multiply it by the conversion factor na 778. 778 feet pound per BTU. Yun. So, cancel na to. Cancel yung pound, cancel yung pound. So, feet squared, second squared ng unit. So, V2 will be equal to, solve natin, square root ng 2 times 32.174 times 778 times yung 1187 minus 1041. Okay? That is 2703. 2703.546 feet per second. That is for problem number 2. Let us proceed to number 3. Problem number 3. A steam turbine. Yan, turbina naman. A steam turbine receives 1,630 kg of steam per hour. So that is mass flow. 1,630 kg per hour. Sir, ano yung turbine? Kung ang pump nyo, ang bomba, okay, nag-consume ng power, Ang steam turbine naman is nagpo-produce ng power. Okay? Or, ito yan, your pump, your compressor are power consumers. Kailangan nila ng application ng power para gumana sila. Itong steam turbine is pinagagalaw lang by the kinetic energy that is contained by the flowing steam na highly pressurized. Ngayon, yung steam na yon, yung kinetic energy niya, i-change yan ng inyong steam turbine into brake power para gamitin for utilization ng power plant para makapag-produce ng electrical energy. Diyan pumapasok yung conversion mo ng energy from one form to another. From kinetic energy to brake power to electrical energy. Ganun yun. Okay? Maintindihan nyo yan pag kayo napunta na ng ating power plant design. So, ito na. Ito daw yung iyong mass flow ng steam at 340 kilometers per second na velocity. So, that is 340 velocity niyan. 340 kilometers ba yan? 340 kilometers per second. Ay, hindi. Meters per second lang yan. 300. Tanggalin mo yung K. Mali yan. So, that is meter per second. Kaya nagtaka ko eh. Ay, 1. Velocity 1. Tapos, enthalpy mo at 1 is 3,550 kilojoule per kilogram. And then, leaves at. Iniwan na niya. Hindi na babalik. So, 259 meter per second. Tapos, ito yung sinama niya nung iniwan ka niya. 3,020 kilojoule per kilogram. Yan. So, meron pa ba ibinigay dyan? Wala na. Which of the following most nearly equals the power output? So, ano to? Anong unit yan? That is in kilowatt or HP. Yan ang hinahanap natin. Ang power output is always hindi heat. Okay? Pag turbine, hindi na heat yan. The power output is the work ng iyong turbine. Okay? Kapag in-specify power output, that is work. Kapag sinabing loss, heat gain, heat yun. So, energy in, energy out tayo. E in is equal to E out. Lagin yung ganito, kaugalian nyo. PE1 plus KE1 plus U1 plus work flow. Kasi steady flow yan. Kasi turbine yan. Meron kang mass flow. So, that is 1 plus Q. Wala namang binanggit na Q. Okay? Ito, dito ka na sa baba para magkasya. PE2 plus KE2 plus U2 plus workflow 2 plus work. Ngayon, cancel out natin yung mga parameters na hindi binigay. So, wala kang PE kasi wala ka naman change in height. Ganun din dito. Itong KE meron ka, KE2 meron ka, heat wala ka. Pero itong dalawang to, ayan, this is enthalpy 1. Itong dalawang to, enthalpy 2. Okay, meron tayo niyan. Ilista ko na. So, KE1 plus H1 equal to KE2 plus U, H2 na yan. H2 plus work. Yan. So, since turbine ito, hindi siya power consumer, so ang power mo dyan will be positive. Nag-produce siya ng power taken off to the system. So, work ang hinahanap natin. Work is KE1 minus KE2. KE1 minus KE2 plus yung H1 minus H2. Kaya lang, hinahanap natin is the power output na. Kaya i-multiply natin to ng mass flow. Lahat, entirely. Okay. So, work will be equal to. Lagay ko na dito ha. Ito muna, unahin ko bago itong mass flow. So, KE1. Ano ba yung KE1 mo dyan? So, that is P1 squared minus P2 squared over 2G. Kaya lang, wag mo nang lagyan ng effects of gravity. over 2 na lang. I-delete na natin. Over 2. Yan. No effects of gravity at all. Plus H1, H2. H1 minus H2 multiplied by M. This is so 1/2 times B1 is 340 ba yung nakalagay? 340 ayun. 340 minus yung isa that is 259. Ang lalabas na unit dito pag in-square natin itong dalawa is meter squared per second squared. Plus, plus naka-hours. So, this will be, yung H1 is 3550. 3550 minus 3020. Check natin kung 3020. Ayan. And then, i-multiply mo ng mass flow, which is, ano yung mass flow? 1630 kilogram per hour. 1630 kilogram per hour. Yan. Solve natin. Okay, so, simplify mo natin, ha. 340 squared minus 259 squared divided by 2. The answer is 2, 4, 2, 4, 259.5 meters squared per second squared. Yan. Plus 3550 minus 30 20. Yan. 530. Ang unit ng is kilojoule per kilogram. Kaya lang ito, hindi naka-kilojoule. Kaya kailangan natin siyang i-divide natin ng, anong dapat i-divide natin dyan pag hindi naka-kilojoule? Kilogram meter per second squared. So, i-divide natin to ng, ang lalabas kasi dito is in newtons lang. Kasi kilogram meter per second squared, ito extract natin. Pag i-multiply natin siya, i-simplify ko na to. 1630 kilogram per hour times 1 hour over 3,600 seconds. Cancel natin to. Dito, focus muna natin to. Diba, kilogram, meter, per second squared. Ayan, may natirang meter pa. Itong buong to is, kilogram, meter, per second squared is in Newton. Correct? Correct ba? Newton. Tapos itong buong to, Newton. Tapos ito, Newton meter, pag pinagsama mo, will become joule. Yan kailangan natin kilojoule. Kaya i-divide natin ng 1,000 joule per kilojoule para maging kilojoule. Kaya ganun ang gagawin natin dito. I-divide natin ng 1,000. So that is 24,259.5 meters squared per second squared divided by 1,000 joule or 1,000 Newton meter per kilojoule. Ayan. Plus 530 kilojoule per kilogram multiplied by 1630 divided by 3,600 kilogram per second. Kaya ang lalabas dito is kilowatts na. Kasi maka-cancel yung kilogram, yung Newton meter, ito, lahat yan. Tapos yung kilogram dito. So, ang lalabas is, so, 24,259.5 divided by 1,000 plus 530 multiplied by 1630 divided by 3,600. 3,600. Yan. So, the answer is 250 equal to yung work niya. Positive. 250.96 kilowatts. Convert natin ng HP. Divide na lang natin ng 0.746 kilowatts. 1 HP. Yun. Divide natin ng 0.746 to make it into HP. So, ilang horsepower? 336.40 HP. That is the amount of power that your turbine will produce. That is for problem number 2. Problem number 3. Problem number 4. Problem number 4, a turbine uses 100,000 pounds per hour. So, mass flow na naman. Of steam that enters with an enthalpy of 1,400 BTU per pound or 3,300 kilojoule per kilogram, and essentially zero entrance velocity. Ay, wala kang velocity 1. So, 10,000 HP daw yung developed or 7.5 megawatts. The exit velocity of the steam is 500 feet per second or 150 meter per second. Expansion is adiabatic, ibig sabihin, zero heat added or zero heat lost. Okay? What is the exit enthalpy? So, E-in, E-out na naman tayo. Energy in is equal to energy out. So, PE 1 plus AE1 plus U. Gawin na natin, ha? Gawin na natin siyang enthalpy na. H1 plus Q equal to PE2 plus KE2 plus H2 plus work. Okay, nagbigay naman ng work dyan. The work is 7.5 megawatts or 7,500 kilowatts. O dapat ito i-convert na natin kagad. So, wala tayo ditong PE, 0. Wala rin tayong PE, 0. Adiabatic ang system, kaya no heat added. Naliwanag ko sa inyo yan. So, 0 entrance velocity, 0. So, ang natira is ito, and ito. Ang kinukuha natin is H2. Exit enthalpy. H2 is equal to KE2, negative KE2, minus work plus H1. Okay, so, pwede natin gawing ganito yung ating calculation. So, equate natin silang lahat sa 0 and yung mga titirang parameters. And then, we will have to simplify this first. So, this will be 1/2 ng KE, which is B2 squared minus B1 squared plus yung delta H. And this is hindi specific yan, enthalpy yan. So, kailangan natin multiply ng mass flow. And then, syempre, ito i-multiply na rin natin ng mass flow. Yan. And then, i-multiply natin ng enthalpy. So, H2 minus H1 plus yung ating work. Hindi na specific work yan. So, work. Wala tayong initial velocity. Sabi dito sa problem, neglect yung initial velocity. Okay, and then, no heat added. So, as is, 0 yon. And then, ano ba yung M natin? Ito yung M natin. Okay? So, 125 over 9. Tapos, yung V2. Ano ba yung V2 dito? V2 is 0 entrance velocity, 150 meter per second. 150 divide by 2. Square natin to. Pero kailangan natin siyang, kasi ang lalabas dito is in Newton meter, kailangan natin ito i-divide pa rin ng 1,000 para maging kilojoule. Okay? Plus, yung M ulit, 125 over 9. times the enthalpy. So, the enthalpies na binigay dyan is 3,300. 3,300. Okay. So, H2, matitira H2 minus 3,300 plus yung 7,500 to make it in kilowatt. Lahat to naka-kilowatt. Ito, pag binultiply mo, ang lalabas din kilowatt. Pero to dapat to is kilojoule per kilogram. Okay. So, paano po ang mas madaling gawin dito, sir? Look at the calculator. Ganito. You let this as X, an unknown value. Okay? Calculator technique tayo. So, this will be 0, alpha equal to yung okay, 125 times 150 squared. I-divide natin yan ng 2, 9, and 1,000. 2 times 9 times 1,000. And then, add natin. So, 125 over 9. And then, multiply natin yung taas niya ng alpha x, kasi unknown to, yung H2, minus 3,300. Yan. And then, add natin ng 7,500. And then, sir, ang next natin gagawin. So, that is shift solve. To solve for x. So, x will be, or the H2 will be equal to 2748.75 kilojoule per kilogram. So, that is how you will solve lahat ng binigay ko sa inyong problems pagdating ng conservation of energy. Now, pwede kayong mag-calculator technique pagdating ng inyong board exam para mas mapabilis yung calculation nyo. Pero, the most basic way para ma-solve nyo ang isang conservation of energy problem is to list down first all of the given parameters na nandyan. And after mo ilista, tignan mo muna kung lahat ba sila is in unified measurements or conversion of units. Ngayon, kapag hindi unified, so i-single out mo lahat ng units na kailangan mong i-convert. And then convert it to 1 unit. Mare, lahat yan, convert mo to power, to HP, HP mo lahat. Okay? Kapag naka-SI, SI mo lahat. Kapag naka-English, English mo lahat. Pero the most important way na kailangan yung tandaan, yung conversion of units, that gagawin mo lang yan pagdating ng dulo. Huwag mong gawin yan pagdating ng unahan. Pero kung hanggat di may iwasan, pwede mo namang gawin. Okay? So that will be all for the 4 problems of your conservation of energy. I hope alam niyo na kung paano gawin. So let us meet for another week, okay, of a new topic. That will be all. Bye-bye.